Hello, and thank you for joining us for today's webinar, Redefining End-to-End Monitoring, Service Model Integration. My name is Gia Mangino, and I will be your moderator for today's event. Today's webinar is the third in our Redefining End-to-End series. Our fourth and final webinar of this series will be held on Thursday, September 25th at 11 a.m. If you're interested in registering for that webinar, you can visit our events page at www.sl.com. Our presenters today are Mike Margulies, SL's Vice President of Sales, and Rodney Morrison, Vice President of Products for SL Corporation. Mike has been an enterprise software technology leader at some of the industry's leading firms, having held executive sales and marketing positions at both Oracle and VMware, and brings a wide range of practical applications, middleware, and infrastructure knowledge to the table for SL and its clients. As Vice President of Products, Rodney Morrison is responsible for product management, tracking market industry trends, as well as competitive analysis for SL. Rodney has had several roles since joining SL in 1988 as part of the development team, including technical sales support, managing software development, developing the VAR network in Europe, and managing sales and marketing efforts in Europe and Japan. Today's presentation will be approximately 30 minutes, with time left at the end to address questions from our audience. If you'd like to participate in the Q&A session, simply enter your question into the chat panel at any time during the event and click Submit. With that, I'll pass it over to you, Mike. Thank you.
Thanks, Gia, and thanks everybody for joining. This is Mike Margulies. I'm really happy to present today with Rodney Morrison, my colleague on the product side. We're going to be talking about the second phase of redefining end-to-end monitoring, specifically about service model integration and the importance of real-world application context into application performance and availability health state. The demands on applications have grown significantly in recent years as organizations expand their customer reach worldwide and are expected to ensure 24/7 responsiveness for customers and employees alike. At the same time, the architectures that support those applications have in turn become more complex, with a growing number of interdependent middle-tier components deployed across global data centers with specialized, often local teams in place to ensure optimal performance and availability for those components. Moreover, many of these underlying components are often pooled and allocated to applications dynamically. Keeping track of which components belong to which applications has become a daunting task, and oftentimes organizations fail to understand these environments holistically and how they tie back to the business itself. This is a huge problem for companies with millions of dollars on the line each time application performance degrades or the app fails altogether. Part of the problem is that traditional monitoring tools have been focused on the infrastructure silos that are common in most data centers. Hardware, databases, app servers, VMs, organizations and teams have grown up around each of these computing silos, and for good reason. Expertise often requires specialization, and IT has become very adept at monitoring each of these specialized silos independently. But what's been missing from the traditional monitoring approach is the ability to see across these components from 30,000 feet and understand the interdependence across them. Which pieces require which others to ensure application health, what an alert in one silo means when viewed alongside another, and how to find the source of a problem without really understanding how all of these pieces work together. So what's needed is a way to do the hard work of normalizing the data, aggregating it and correlating across it, analyzing it, and hopefully predicting and taking proactive steps to address problems before they become problems. Traditional monitoring has imposed a brick wall over these silos, making it impossible to view them as part of an intertwined web of dependencies divorced from the applications that they're in business to serve. What's required in the face of this increasing complexity is a new kind of monitoring, what we're calling redefined end-to-end monitoring, not the old definition of end-to-end, digging down into the code and transactions or the logs themselves to see every granular detail, but a redefined end-to-end view that unifies data sources and promotes 360-degree visibility across all of these applications and the IT resources that support them. Real end-to-end monitoring allows for application and infrastructure level views with complex access to real-time and historical performance and availability metrics, events, and trends. The important thing to realize about silos is that they provide an incomplete view of the factors contributing to application health state and how to prioritize attention to these factors. It's applications themselves that drive the business, not the hardware, middleware, or other pieces of the puzzle. More importantly, visibility into holistic application health is something that the business needs, not just specialized IT teams. Application owners need advanced warning if something is wrong, and the ability to identify who to call. Thus, visibility needs to be configurable by role and provide a view from the network level all the way up to the application level across all of the computing tiers, and provide the flexibility to move up or down the stack from any entry point. Lastly, all these teams need a way to prioritize alerts based not only on the severity of the problem, but also on how critical the application is to the business. So in order to deliver on the promise of real end-to-end monitoring across these applications and tiers and vendor stacks, what's required are three primary capabilities. The first, as we discussed in the previous webinar several weeks ago, is a high-performance data collection and aggregation architecture designed for very low latency applications, leveraging a distributed data model and in-memory caching to capture all the data and efficiently store and process that data close to the source, minimizing overhead. The second is an integrated dynamic service model that relies on multiple sources to collect and validate the relationships between organizations, individuals, applications, and the resources that support them. We're going to be talking about this today. And in the final webinar of this series, we're going to be talking about the last piece of the puzzle, which is the ability to correlate and visualize complex data sets so as to provide monitoring intelligence tailored by role and look and feel so that the right data gets into the right people's hands so that they can take appropriate, timely action. So thus, real-world context is absolutely required for individuals and organizations to make sense of the thousands of boxes that are supporting these applications, the huge flood of alerts that people are getting at any particular point in time. They need to figure out dynamically which virtual resources are allocated to which applications and services so that they can connect the dots between all of these interdependent parts. And more importantly, they need to be able to distribute the actionable data about application health state, democratizing that intelligence, not having it reside only in silos, but being able to provide application owners and application support teams from the LOBs with access to health state information so that they can get advanced warning about what's going wrong and action a remediation plan before the application fails altogether. Now I'd like to turn it over to Rodney to talk a little bit about the maturity curve and some of the problems that service model integration seeks to solve. Rodney?
Thank you, Mike. Before we get into the technical aspects of the RTView EM service model, I wanted to provide some context to explain the benefits of a service model within a daily workflow of managing application health. And to do that, I'm going to describe some typical steps that organizations go through to figure out how do I deal with these many multiple monitoring silos. And the first step that people approach this problem by usually involves sending notifications out to the teams from the various monitors themselves. The second involves event management tools, which I'll cover a little bit in detail next. And the third describes end-to-end solution with RTView EM. And finally, a description of the benefits of integrating that solution with service desk tools. So first, let's talk about people that care about application service health. The line of business, and there's many groups even other than the ones I listed. The line of business has interest in understanding the level of service provided to their end users or customers. Operations is first-line support and has expertise on all the components of the hardware and software infrastructure, but has limited understanding of application architecture. And then the application support and development teams have a deep understanding of the architecture of the app, but are typically called in when operations identify that it requires their expertise to analyze it. So as organizations grow and expand to multiple technologies to support their applications, each technology comes with its own admin and monitoring tools. And the challenge then becomes how to get the correct information to the right people, how to analyze the situation across multiple technologies, and then ultimately resolve problems before they affect end users. So the first approach here, described here, is notification. So they set up email or SMS notifications from issues discovered in the silos. And when this happens, in even small organizations, they can deal with thousands of notifications per day when it's initiated. And because of that, this is often not even implemented for the line of business, because that would just cause panic. They would have no context as to whether any of this information is affecting service levels. And it's often, though, however, implemented for the app support and dev teams. But usually what happens is they end up ignoring this information because it becomes noise, where they can't differentiate when an event is something the operations teams will handle as part of daily operations or one that actually requires their expertise. So really, in practice, this model ends up working like this. The op teams are the only ones that look at the notifications, and over time and practice, they discover which events are interesting. The events then point them to which siloed admin and monitoring tool to use for analysis, and after that analysis, they may discover an event requires some action to be taken, and then they manually enter it into their trouble ticket system to get that resolved. The trouble ticket then also works as a silo where the workflow necessary to resolve the situation has limited context with the event that actually initiated it. That whole process is obviously time-consuming, error-prone, and requires some deep analysis expertise by the operators. And there's very limited proactive measures that are even available for the app support or dev teams. They're only brought into the process if operations manually indicate to them that something must be done. So let's look at a second step that people try to do to get more maturity in how that process works, and that's usually when they try to initiate event management tools. And event management tools work as an aggregator of those alert events provided from those multiple sources. And that allows better management of the alerts by the various teams, because those tools provide a way for multiple teams to visually look at the list of active alerts and filter by alerts to find the ones of interest, and then perform actions on the alerts to indicate status such as, I need to close that one, suppress this one because it doesn't matter, or own it, saying I'm going to look at this one and analyze it on my own. So those teams can then work in a much more coordinated effort to determine who needs to analyze the alert, and after analysis, determine if a trouble ticket should be raised. There are some limitations with this mode of operation, though, because event management tools often only have the alert events themselves, the indication of a problem. They do not have access to any of the performance data that raised the event, and therefore each team must go back again to the siloed systems to do analysis. And this mode also requires some deep knowledge in order to solve a problem that requires analysis across those silos or technologies. It's also very difficult to determine how to prioritize the events, determine which teams need to have access to it, or there's no context between the event and the services it impacts, or which team cares. So now I'm going to talk about the maturity level that RTView EM provides, and in some cases, people already have existing event management tools, and we could integrate with those as well. But sometimes our customers can leapfrog to maturity level 3 by having RTView EM that combines a variety of services there for you. One is event management itself, helps different teams manage the event process, and then cross-correlation analysis right there in that tool. They can actually look at the data and do the analysis right there. And then what we're going to talk about more in detail today, the dynamic service model that provides context as to what alert affects which service, and can help you prioritize what to work on first. So let's describe a little bit how the lives change for each user when we get there. Line of business. So they finally get a view of what's going on that makes sense to them, including views of application and service health that they own, and their current and historical health state of those services. Operations. They finally get out of the mode of having to visit hundreds of siloed admin tools to do analysis. And this isn't just one per technology. oftentimes a certain admin or monitoring tool can only look at a certain domain. For example, if you're monitoring WebLogic, you might have to go to 10 different domains to get its full scope. But here all the information is at their fingertips with deep out-of-the-box correlation views to look at component health state. They can also view health state across technologies to see if a certain technology platform is working well, but then also look at service model criticality to say, here's the app that is really important to the business that's in critical mode right now. And last, the app support and development teams, they finally get something more than noise, and it can actually be proactive. They get top-level views of application and service-level health that are applicable to only the apps they care about. They can filter out low-level infrastructure-based alerts and focus on the ones that might have app impact. And they can drill down to the component level that are supporting those apps to do deep analysis. Because what happens in most organizations is the app teams do not even have access to those siloed admin tools. So they really have no access of way to analyze the problem. So they fly blind without necessary data to do it. And finally, all these teams together benefit from having a central place that all teams can use to manage analysis efforts. I wanted to talk a little bit about how some of our customers go an extra step here, which is possible also with RTView EM, which is to integrate with service desk or trouble ticketing systems. So oftentimes the trouble ticket system is really a silo of its own. When support teams raise a ticket, there's no correlation between the event management system and the state of tasks that must be completed to resolve the problem. And so with this workflow, the support teams, after analysis, raise a trouble ticket, and what happens in RTView, that's correlated with an event in RTView EM. They can look at list of alerts and choose, this is one I've analyzed, and I need to raise a trouble ticket, and with right there in the console, they can say raise a trouble ticket, and that RTView EM then provides information back to the trouble ticket system correlating that alert event ID so that we have a correlation between the trouble ticket system and the event management system. The trouble ticket system can then provide data information back, that's why it's bidirectional, to show when we're looking at their list, what's the state of that resolution happening in the trouble ticket system. So that way people can see what necessary tasks need to be resolved and what state they are in resolution, all in one console. So now let's go a little bit into how RTView EM does it. First, let's look at the EM architecture here. This is the top-level box here is the main platform of RTView EM, and there's three components that are related to providing the service model benefits to end users. The first, on the left-hand side, is what we call the config server, and it's used as a proxy to gather all inputs to your service model, and in the next slides I'll show you what kind of inputs it can gather. The alert server then takes that service hierarchy and creates an in-memory dynamic service model, and it performs the necessary calculations to determine the health state of your model using the collection of all real-time alert information and severities of alerts that it's gathering from multiple sources. Finally, on the right-hand side, the display server component. It's used to provide the role-based views into that service model, which give each user their specialized view into the service model and related alerts and alert severities. So let's talk about constructing the service model itself. The service model is used to designate the individuals and groups in your organizations that have interest in or are responsible for the health state of your applications, your services, or the infrastructure. The top part of the tree of the service model is more static, and it changes often only during reorganizations of people. The bottom part is more dynamic and changes as new services and supporting CIs are added to your system. In this context, the CI stands for what is a configuration item, and it indicates an item that's being monitored. For example, it might be a physical server, a virtual server, a database, an application server, or even more granularly, it could be a queue in a messaging piece of middleware. The levels of the tree also are pretty flexible for your use case. For example, the notion of a service here in this picture might be a true service or application, but it could also be something more aligned to your support team management, such as like the WebLogic service, which captures many WebLogic server clusters. So associated in defining the service model is also the notion of criticality. Particular services or CIs can be given a criticality level to help in the prioritization of components that deeply affect a service, but then also the criticality of services that deeply impact the business. And the main role of this service model is to get the information to the correct people in a form they can act on and prioritize their efforts. So let's talk about the inputs to the service model. Depending on the size of your organization and maturity, organizations have many varied sources for their service model, and RTView provides simple integration steps for including those sources of data and joining them together to form a complete model. So parts of your model might come from asset and change management systems or even from your service desk system. RTView also has auto-discovery features that can detect a new CI and automatically associate it with the service. And finally, there's a service model editor, which is an interface in RTView which allows end users to configure or modify the service model themselves. So in many medium or small-sized organizations with 20 to 50 apps to monitor, they choose just to manually manage the service model, and that's either because they do not have existing sources of data or because it is a relatively small effort that doesn't justify an integration with other data sources that they have. So let's talk about the dynamic service model at work. So once we have a service hierarchy, the dynamic service model is an in-memory, real-time model of the health state of your systems. And what happens is that real-time alerts and alert severities are used along with the criticality of the component or the service to determine the health state of any leaf within your service hierarchy. End users then can have their specific defined view into that service hierarchy to ensure that the health states that they're looking at or interested in are available at their fingertips to analyze and understand how to resolve the issues. So we're going to go over this actually quite a bit in detail in our next webinar coming up, talking about correlation and visualization functionality of RTView, but I'm going to give you a brief view here because it's relevant to what we talked about today. And first of all, I just wanted to talk about the heat map here. And there's a heat map version, and it shows boxes with gradients between green and red that show the health state of each service. Then there's also the ability to drill down from that to the component level to see the components that affect that service, and finally drill down displays to show individual component detail with historical detail. So here's a closer look at the heat map, and we have also tabular views of this information. It shows different areas or groups of interest, and it also shows in the box is really the service. And the color shows you is it completely healthy, green, is it not healthy, red. And the size of the box indicates the complexity of the service, how many things are being monitored to determine its health. So this view is often used by most all teams. Line of business and operations and app support all gain value in understanding which service really needs attention. And from that, you can click on one of those boxes, and you found one in danger, and you can look at the overall infrastructure that supports that application. So in this example, they're TIPCO-oriented. They've got business work engines and EMS servers. They've also got Oracle databases and Tomcat app servers. And the one that's causing the issue is an EMS server. And then you can really drill down to look at the analysis of that EMS server itself or any CI that's causing an issue and determine with historical information at your fingertips, what was the issue? Is it trending? Is it spiking? Is this an issue that we need to actually raise a trouble ticket against? And I'll show you one last view. This is a service status history display, which shows the health state of each service over time. It shows the current health state, what it is now in the list on the right. Each service with a little bubble there to show green, yellow, or red status. And what's on the left is the history. So you can determine the history of the service levels of that service over time. You can also hover over the areas of the bars on the left to determine why it was in that state at that time. So in many cases, the service health is fluctuating, and you may not capture that by only periodically looking at the current health state. This one is often a popular one to look at for the line of business because it shows the service levels for various customers or end users And it might be helpful in prioritizing and identifying which services might benefit by investing in capacity or refactoring efforts. So in summary, the service model is really about getting the right info to the right people. One of the really great things about RTView EM is it's extremely flexible. It doesn't hard code you into a certain organization structure. You can get information from your existing systems and make it really reflect how you organize your support teams to solve problems. And it provides automatic role-based views for those different users of the system. And with that, it helps prioritize the issues that are going to impact your business. A key part of the service model is prioritization of effort. And with that, it becomes a key tool in proactive, efficient, and collaborative management of all your systems. So that's the end of my presentation today. With that, I'm going to pass it back on to you, Mike.
Thanks, Rodney. And I'm just going to summarize with a couple of quick points here. We talked in our last webinar about the importance of a high-performance architecture and making sure that your monitoring architecture can keep pace with your low-latency applications. Obviously, you want to be able to collect and visualize data at a level of granularity that's consistent with the application performance requirements itself. Today we talked about the importance of a dynamic service model and how it's important for application teams and lines of business as well as the infrastructure and middleware management teams to really see this stuff holistically and tie it back to the application level in terms of severity and criticality and prioritization. And in our next webinar, which Gia mentioned was going to happen on the 25th of September, we're going to drill further down into some of the visualizations that Rodney previewed for you here and talk about cross-correlations and visualizations and how RTView provides some unique benefits there with respect to the competition. So this has been dynamic service model specific. What I wanted to do before we open up the floor to questions is just talk a little bit about some of our customers. SL Corporation has been around for quite some time, and we have very many medium-sized as well as large customers in our customer base. And all of these customers have a number of different monitoring tools in production, tools like Nagios or SolarWinds or other stuff to do hardware-specific and compute-level hardware and network monitoring. There are individual tools that are used for specific middleware pieces of the puzzle. But the reason that all of these customers use RTView and continue to not only renew their software maintenance with us, but also purchase new solution packages as they roll out new pieces of their infrastructure and middleware. For example, open source tools like JBoss, for example, or RabbitMQ or Cassandra, is that we are a unique provider of this application-level, holistic visibility into health state. Without a service model, corporations and individuals are left to sort of try to make sense of what is essentially a whole bunch of sort of equally weighted alerts and health state metrics. Only with a service model can these organizations really understand, especially as they grow in the modern context into 24/7 worldwide organizations that have to serve their customers through very, very large operating windows. Only by integrating a service model can these organizations understand how to prioritize what's going on in application health state and allocate resources appropriately to remediate the problems that are most important, while deferring the problems that are, frankly, of less importance. I mean, there's a lot of organizations out there running expense reporting applications, as well as trading floor applications, for example, in a financial services company. We would never want to deprioritize the importance of a trading application that relies on split-second decision or frankly, sub-second decision-making in favor of an application that's really just targeted towards internal processes like expense reporting or a travel application or something that we're all familiar with. So it's only with a service model that we can allow these organizations to sort of free up their resources to prioritize themselves in an effective manner, and thereby not only bring down the costs of both planned and unplanned downtime and performance degradation, but also do a better job of leveraging the HR resources that they have at their disposal and managing capacity so that they're not overspending on hardware and software, and we're supplying the right horsepower for the right applications and optimizing the underlying infrastructure and middleware components that support these applications. For more information, you guys can visit us at sl.com, and you can either request a demo or an evaluation. There's white papers for download. There's videos. There's customer testimonials. And our next webinar is going to be in about a month's time, 11 a.m. Pacific on Thursday, September 25th, where we're going to be talking about cross-correlation and visualization. That's going to be the fourth in our four-part series, and we hope that you all can make it to that. And with that, I'd like to not only thank Rodney, but everybody who participated on the audience side, and open the floor up to any questions. If you do have any questions, you can use your chat window, and then Gia will announce those questions, or Gia, I think, has a few questions already that we've teed up here. So I'm going to pass it back to Gia and the rest of the audience for Q&A.
Okay, well, thank you, Mike, and thank you, Rodney. Thank you also for reminding everybody about our next upcoming webinar. I would like to let everybody know that we did record this webinar, and I'll be sending that out within the next few days. If you would like to submit any questions, you can do so through the chat panel or the Q&A section on the right-hand side of your screen. We do have one question here from someone that says, I wasn't clear on how the data about the health state is flowing around in the system and to the tools. Is that through a web service, or is that something else?
I guess I'll take that one.
Thanks, Rodney.
As I talked about as far as the information flow, we're getting information about your service model from various sources, so that's really the structure of your organization. And then we're gathering the alert events. Those can come from what we call solution packages, monitoring specific technologies, finding alert thresholds or crossing alert thresholds and pumping that alert severity and alert information to our alert server. From that, that's where when I talked about the dynamic service model, that's where the calculations come about what you define as the criticality of your service, combined with the severity of the alerts, you can get those top-level views. So where it's flowing around the systems is we're gathering those alert events. We're then doing the dynamic calculation of how those alert events impact your services against the service model.
Okay. Thank you, Rodney. Can you look at information across production and test environments?
That's an interesting question, and one that I hear a lot when I interview our customers after deployment. And it changes a lot of things as far as the dev and app support teams go, because they actually have a full view with all the detailed information of the components and the health of their components when they're in dev and test environments. And then what's really important to them is there's a change event, and they're getting ready to put stuff in production, and they can look side by side within the same tool. Here's my test environment or the dev environment. Here's my production environment. Are they acting the same? And that gives a lot of comfort when those sort of nerve-wracking changes happen, and they're worried about what will happen when it actually goes live.
Okay. What is the process for including various pieces of service model information from different sources?
What hasn't been described here is that RTView EM comes with a standard, what we call RTView Core product, and it's a desktop environment that has a variety of packaged data adapters available. So let's just take one data adapter, for example. Maybe part of your service model is in a database from some change management tool or other source. So you can just, with dialogues, you can go and query against that data source and decide how often you want to query against it. And then there's transformation and joins you can do to join that information with our RTView service model or other parts of information. And that really then happens, dynamically. So as those sources of information change, your service model will change. It's not like you have to gather them all together and push that information at some point. It will happen dynamically using the data adapters that we have from our RTView Core configuration system.
Okay, thank you, Rodney. We do have one last question. Do you recommend integration with all monitoring silos or to use RTView EM to gather its own monitoring information in some cases?
That's also a very interesting question. In general, RTView EM has solution packages, and they can go about gathering monitoring information. Let's just take WebLogic, because I talked about that before. So you've got your admins or other monitoring tools that are monitoring your WebLogic silos, and in reality, we would recommend that you use our solution package rather than integrating with those other monitoring tools, because we get more granular information. We have packaged views against that. We have packaged alerts against that. We have packaged deep correlation across the different clusters you have for WebLogic, and it has some granularity as far as how often that information is being gathered. Sometimes those silos are very slow at gathering information, and we can gather that information ourselves. So the other important part of RTView EM is it's basically an agentless system. So to take that example, we're not making you install agents on those WebLogic hosts. We can just remotely and agentlessly collect that information, so it doesn't put more load on your systems to have RTView gather that information. It actually gives you much more and deeper information than you actually get from your silos itself. That said, there are some cases where you just want to keep that monitoring information, and oftentimes that happens with your host-based monitoring systems, where you're gathering CPU and memory statistics about hosts, and oftentimes those are integrated into RTView from that monitoring silo.
Okay, well, thank you very much for all of your questions, and thank you, Rodney and Mike. Unfortunately, we're out of time. Again, the webcast has been recorded, and I'll be emailing a link to that recording within the next few days. Thank you, everyone, for joining us, and have a great day.
Thanks, everybody.